Alright, here we have, oops, giving away something for the future there. Here we have a multi-directional force problem. We've got a 25 kilogram mass sitting on a table. It is attached by a rope, which is then attached to a wall, and hanging from that rope is a 10 kilogram mass. This angle here is 20 degrees. The question is, what is the minimum coefficient of friction we would need between the table and the block in order for it not to slide? So let's do a force diagram, because we got everything standing still, so we need forces to add up to 0. First force we got is downwards here. Okay? Force of gravity. Then we have the force pulling upwards there. Okay? We have a force pulling to the right. Okay? And we have the force of friction pulling back. Okay? And those four forces have to add up to 0. So, since we know this one's Fg is going to be 98. So that this also is 98 newtons. Now, from that, we know that a string or a wire or anything like that in that kind of orientation is going to have proportionally the same, or we can find out what the force is to the right based on just some trig. So we can sit there and say, okay, we know the x is 98 over x, or the force, let's call it the force to the right here, the force to the right, is equal to tangent 20. And that's going to come out to be 269 newtons. So we now know it's being pulled 269 newtons to the right. Okay? Now, we also know this force of friction to the left has to be equivalent to that, otherwise it's going to start to slide. So we say, okay, 269 equals the force of friction. Force of friction is equal to normal force times coefficient of friction. The normal force for this is going to be 25 times 9.8. So we set it up as 269 equals 25 times 9.8 times µs, and we get the coefficient of friction to be 1.1. Now that's a pretty high coefficient of friction. That makes sense. The idea of holding a 10 kilogram block from something like this, and I only have a 25 kilogram block doing it, that's at that kind of angle is pretty tough. Alright, so there's a multi-directional forces problem.